I'm going to create a new database and leave lock configuration by default. So I'm going to create a table big rows and set the full recovery model with full backup of the database. So how to check how many VLFs are inside the lock? DBCC log info is the right statement, and here we have 4 rows, and that means that we have 4 VLFs actually inside the lock when it's initially created. So every VLF, every row is a record of a VLF and explains one VLF. So VLF has a size, has a start offset inside the lock, has a sequence number, which is important to know, because now I'm going to run some activity against the lock, and you see that those sequence number are increasing, and they actually are showing which one after which consequently are placed or follow inside the transaction log. The status of the VLF could be 0 or 2. There is no 1. I don't know why, but there is no 1. They are just 0, which is zeroing or inactive, and status 2, which is active VLF. So here we have recovery unit ID, which is probably something that will be utilized in the next SQL Server version. For now, it's just a column inside and it's just 0. So this is the parity column. The parity column is actually the parity for a VLF, which could be 0 for 0 initializing VLFs, 64 or 228. So when the VLF, or when the lock is cycling, then the parity of the VLF is flipped in order for SQL Server to know how to read the lock during the recovery, during the backup, and during all those operations inside the lock. So let's show some activity and something that is changing or creating the VLFs inside the lock. Okay, so this is the activity that is going through the lock. So after, here we go, you see the VLF is becoming active, is changing its status to 2. Its parity is the parity of the previous active VLF, and sequence number is continuing the previous VLF. So after reaching the end of the active VLFs, because we don't have a place inside the lock, the VLF is creating again, so we create another portion of the VLF files. And because the file chunk of growing is 1 megabyte, which is below 64 megabytes, then for one chunk, for one growth, 4 VLFs are created. And what's happening when the VLFs are creating again, the transaction log is becoming fragmented, because they increase as a number far beyond 100, and the transaction log becomes slow on reads and slow on writes. What is the proper action here? The proper action is actually to back up the log regularly in order to prevent the log from increasingly growing a lot, and of course to configure the log properly. So I'm going to back up the log right now and to show you how the VLFs are cycling. So what is causing the log to cycle and to start from the beginning? Here we go. So you see we have a 55 as a sequence number of the VLF, and the next VLF, because it's inactive because of backup log, so 56 is the beginning of the transaction log file. So that is the way the log file, here we go, the log file is reused internally as VOFs. Okay, so and because we have those inactive VOFs, we have enough room to grow inside the file, and we don't need to increase the file physically or to create another portion, another file chunk, and another VOFs. You see the parity is flipped from the beginning of the file, and when if we don't perform a regular backup lock operation, then the file will grow again. So here we go. And this is actually the % log file used counter that we see. How much of the log file is used against the overall log file. The only action that is available, what is right here, is to perform a regular backup lock operation. So how to deal with fragmented lock? What action we have to take in order to configure our lock properly? So I'm going to compare those two tests from the beginning of my demo in order to see the difference between the VOFs in first case and the VOFs in the second case. So in the first case, I have see here I have 151 VOFs in the first transaction log file when I run my test with default settings. In the second file, in the second case, I have 16 VOF. The physical file is the same size. So how to deal with the log file fragmentation? First of all, I have to take the proper action, which is the following. So I have to backup lock if the lock is fragmented actually, and I have to defragment the file lock. I have to choose a time in the day when the workload is not so intensive against the database in order to do that. What is my goal here? Actually, my goal is to shrink the transaction log file at its minimum and to configure properly after that, to increase the initial file size and to set up the proper growth settings. This is the ultimate goal here, to reduce the fragmentation. Those are the steps actually. So first step is to perform the backup lock. And the second one, you see, the backup lock takes a long time to complete. And the second one is to perform shrink physically the file. And this is the only case when you actually use the shrink statement. So after that, here we go. I'm going to check if, oops, sorry. Okay, so I need to backup lock again. Okay, 3 pages, not more. Then yes. So you need probably to perform several backup statements, several backup locks to shrink file in order to really shrink file at its maximum. And after that, perform a transaction log file configuration. So configure proper size of the transaction log and the proper file growth of the transaction log in order to perform well. I'm sorry. Okay. These are the right steps of configuring your transaction log file or reducing your transaction log file fragmentation. So Of course, you should monitor your transaction log file further in order to ensure that these steps are really the right steps of log file configuration. Here we go. We have 12 rows, so 12 VLFs created for the log file size of 1 GB. So, what is the right way to do that? Actually, we have to put initial file size of the transaction log file. We have to put some growth settings and to monitor for a period of time. To monitor the VLF number of VLFs, and if the file is growing or not. So our ultimate goal is to not allow log file fragmentation or to keep VLFs under 100, and to not allow a dramatic file growth to perform, so to keep the log stable. So we are allowed to play with configuration settings, which are our initial size of the file growth, to perform regular backups in order to keep the file not growing anymore. So to have a right maintenance strategy, of course. So every grow of the transaction log file, especially when the settings are inappropriate, cause the performance problems with the transaction log file. If you have a lot of write log waits in your system, write log wait actually is showing directly that you have a slow log file. So the action are to put the transaction log file on a different drive, to isolate the transaction log file. It's a good practice to test beforehand, before you put your transaction log to the specified drive. Test your drive in order to get the latency, the proper latency, or to have an idea what is the latency of your physical drive or the LUN, and to test and benchmark the write and sequential writes and sequential reads of the transaction log file when it should be on the specific drive. What are specific about or wrong action about database maintenance? So there are a lot, of course, but some of them, or very important of them, that could cause problems with your database performance or with your corruption survival techniques. So they are so-called sounds good tasks in the maintenance plan. Very often people just pick those tasks and include them inside the maintenance plan because those tasks sound really good. And one of them is shrink database. And now is the time to realize what the shrink database actually does. Especially, I noticed that especially SQL Server DBAs that are coming from Windows environment or from Windows DBA, they tend to use shrink database regularly as a maintenance task or as an auto option of the database, because they are used to keep the volume in a controlled way. So if we have empty space inside the file, it's something wrong. So we have to shrink in order to leave the space enough space inside the drive, which is a wrong action actually inside the SQL Server. I will show you. I will show you shrink database in 2008 because I'm going to use an internal viewer. And there is no internal viewer add-in for Management Studio on SQL Server 2012. So that's why I'm using a virtual machine with 2008. So what I'm going to do is I have a shrink demo database, and inside the shrink demo I will create two tables. approximately 10 megabytes each. First table will be named first in file with a clustered index, and I'm going to fill it with data, approximately 10 megabytes as I told you. And I'm going to create a second table, again with clustered index, which will be placed inside the file right after the first one. Here we go. Oops. Fill with data. So we have two tables. We have 20 megabytes database file. And those two tables are not fragmented at all because they have just a cluster index created on them. And they are right to each other inside the database file. What it looks like. Let me show you. So here is my database file. Okay? So this is my first table in blue. This is my second table in green. And let me show you what are the pages and how the page looks like in my second table. So this is a friendly view of a page. And what is important here actually? First of all, this page has this number, you see, 1956, okay? So my next page is 1957. My previous page in 1955, which is pretty good, yeah. So let's do the following. Fragmentation of the second in-file table is approximately 0. It's not fragmented at all. It has 6 fragment counts, which is continuous pages inside a block. Okay, I'm going to drop the first table, and after that, I'm going to shrink the database. So the viewer, well, forgive the viewer, actually it's kind of, it has a lot of bugs, but it do the right things right now. So this is the status of my database. I removed first table and I'm going to shrink the database in order to free 10 megabytes because this is a free space, okay? So what's happened? Well, the shrink database algorithm is actually creating the following. Okay, this is my file. It's, well, in order to do that, to view that again, I'm going to use it again. To start it again, here we go, this is the right thing. Okay, so file is reduced and it looks like, it looks okay, but let's see what happened. So the page is 797, the current page. My next page is 796. My previous page is 798. What does it mean, actually? The algorithm has picked up last page on my table and makes it first page on my table. And so on, flipping and switching my pages in absolutely inverse order, which actually creates a huge fragmentation about 99%. Let's see. Oops. It's about 99% fragmentation. And that's because all the pages inside the table are not contingent. This will harm the performance of scanning this table because it couldn't be scanned in the whole block. So it couldn't be optimized as a scan performance. So this is the terrible, actually, the terrible action which is going to be performed every time you execute the shrink database. And think about using the auto-shrink option of the database, which is performing shrink database, for example, on every half an hour, which is kind of stopping your database every half an hour. Why stopping your database? Well, it's because it takes not just creates fragmentation, but it takes a lot of IOs and a lot of resources, CPU, IOs, etc., against your database. So it's really an option that shouldn't be used at all. What actually should be performed in order to reduce fragmentation? You have to rebuild an index, okay? Or reorganize an index. If I choose to rebuild an index, not to reorganize it, then see what happened. So I realized that I reached a fragmentation to 99%, and I have to deal with that, with rebuilding an index. If I rebuild an index of the second in file table, then guess what? The database will grow again. So why to perform a shrink database when the database will grow again after the first index rebuild, for example? So this is actually the point. Do I need to perform a shrink database at all? Here we go. We've been there, yeah, just before the shrink database. So when you have to perform, or when you think you have to perform the shrinking of the file, you have to think again, actually. If this space will be reused in your database, it's needed in your database for the maintenance, for example, for index rebuilds, or for when the data has to be loaded inside the database, when really you don't need this space inside the database, then you have to think about the different way of doing things. For example, create another data file, load data, or rebuild indexes inside the new file group, and remove the old file. This will not this will not result in so high fragmentation of the file. What about the cost of the shrink? Shrink costs a lot. Shrink costs a lot of I/O, a lot of weights on IOs. So it's just read all your database, and it's something that you don't want to do to perform while your database is performing workload. Okay, so don't use that, really. Very often I hear about update statistic with full scan as a regular operation against a regular maintenance operation against the database. Well, it is something that that is really kind of troubleshooting a specific query performance, and it's not something that should really be done on a regular basis. Update statistics with full scan is a serious operation which scans a lot of values on your columns, and you really rarely need a full scan of statistics update. So the good practice is actually to leave the samples of the statistic update as their default. If we have any troubles with specific query, and we have to tune the specific query, and you realize that the query probably has the cardinality error, or according to statistics, as a root cause of cardinality error, then we can just rebuild the statistic with full scan and try to realize if this is the problem or not. But rebuilding statistic with full scan is not actually a regular maintenance operation. And the reason behind using the full scan, the update with full scan, is probably using the maintenance wizard, I mean the maintenance plan. And we have the task update statistics when we don't have so much options than specifying with the full scan of specific percent. My advice in such cases is just use update statistics statement. Don't use a maintenance plan update statistics task. Just use execute SQL statement if you still use maintenance plan wizard, but use execute SQL statement and use update statistics SQL statement in order to execute update statistics on your database. What about index maintenance? Well, there are actually three cases that are most common as wrong practices inside the database, as a maintenance in the database that I noticed during my projects. First of all is rebuilding all indexes at once. So just pick the task from, the people just pick the task from the maintenance plan, rebuild index task. They just put all indexes because it's very easy to do that. It sounds great actually. It's visual. And it's easy to be done. So the main understanding is when it's there, it should be used. But it's not so true, especially for Management Studio. So be careful when updating or rebuilding all indexes in your database. It takes a lot of time. It takes a lot of resources. It takes a CPU. Well, you can reduce max DOP, for example, for index rebuild procedure, but it still takes some resources. It takes a space and IOS inside your database, or depends on the setting inside the TempDB. And of course, if the rebuild is offline, then your database or your table is offline during that process. So if you don't rebuild any indexes at all, then you'd probably have fragmentation of clustered indexes inside your database. Well, the reasonable question is, do I care? Well, probably you don't, because fragmentation is not necessary to be a problem in your database. It costs scans of your tables, and it's something that is very hard to define that it's the common reason or it's the root cause of the problems, the fragmentation of your indexes. Actually, you can just check if your indexes are fragmented and try and decide if it's something that could optimize performance of your scans. So it's about clustered index and non-clustered index. So I don't care about heaps, of course, and I don't care about small tables. I don't care about tables that are used not very often or not at all. So I have some filtering of what indexes should be rebuilt actually. So why don't I create a just filtered index rebuild, which is select indexes that are fragmented, that are not heaps, that are not that are below 30% logical fragmentation, or that are used most often using sysindex usage stats, sysindex physical stats. And using those DMVs, actually, I can create an algorithm, filter those indexes that really needs to be defragmented regularly, and just run rebuild index procedure on those indexes only. So I provided a link to you with the code for filter index rebuild in the next slide you see. So next problem, use online index rebuild with no planning. What does it mean, actually? Well, online, do you believe that there is a really online index rebuild? Yes, no? Okay, how many of you really believe that this is purely online index rebuild? No one. Great. Okay, so let me clarify this. Actually, it is online, but at the beginning of the online index rebuild process, SQL Server takes a schema lock. The same schema lock is taken at the end of the process. You know that schema lock is something that you can't combine with a lot of other locks, okay? So either at the end of the process, for example, either your query should wait for the index to finish, index rebuild to finish, or your online index rebuild should wait your query to finish in order to obtain the schema lock on your table, for example. So in other time, it's really an online. But at the beginning, at the end of the process, it's not an online. Actually, this is something that your query should wait or your index rebuild should wait. If I configure only online index rebuild, then I can probably end up with the process taking 1 hour in some cases when the workload is low, or you're taking 12 hours, the same index rebuild, when the workload is high. So sometimes it's really better to have a maintenance window and to have a predictable offline index rebuild for specific indexes rather than choosing online index rebuild and not knowing when the process will finish. So I'm not going to talk about this. Yeah, this is something that should be presented on the slide, but I'm not going to talk about it. Well, really, I had cases when I just, for mission-critical databases, when I asked, why don't you have a backups on every hour, for example, your transaction log, they said, well, we have a clustering, okay? So the next point is important. Please test your maintenance plan. Why is important? Because we have to know every steps what it takes as a time in order to make a proper scheduling for the maintenance plan. We don't want to mix the schedules. I don't want, for example, to perform index rebuild and to DBCC check DB on the same time. No. It's not something that you want to be executed as a database maintenance. So every task should follow, should start after the previous task is finished. Absolutely necessary. Okay. So here are the maintenance worst practices and avoiding maintenance worst practices recommendation as a summary. Here are the links for filtered index rebuilds and for online index case. If you want to use a code that is already developed, please do. Use DBCC CheckDB in your maintenance plan. I'm not going to go into details to DBCC CheckDB, but take care that we have to take an output of DBCC CheckDB properly, because DBCC CheckDB could complete or could finish, but the result could be something that we have to grab in order to find out if something goes wrong. There is a data page inside the data file that contains the last successful or unsuccessful, or the last way the CheckDB finished, actually. You can check this data page. Okay, and the last point in my presentation is something about corruption survival and corruption survival worst practices. First worst practice and first worst thing about corruption survival is, well, it will not happen to me. Well, it will someday, so better be prepared. And when it happens, we usually press a panic button and do things that usually are wrong as an actions. What things are tried first? Restart SQL Server, my favorite. Well, it doesn't work in that way. It doesn't work because you enforced auto recovery process through all your databases. And if you have a problem inside the database, it will not resolve your problem. It will just delay the problem resolution and increase your downtime. The second one is just immediately jump to the last resorts of running repair or running the database in emergency mode or rebuilding the transaction logs. Probably it's not necessary. So thanks God they removed this option, because it was something that people were constantly doing in prior to 2005. They just detached a suspect database, and it became worse. So they changed it, and now you can't detach a suspect database. What is the final result of database action? Could be total data loss, and could be the resume or CV update. Okay, the last demo is something that is interesting as case, and that's the last I will going to talk about today. So we have SalesDB, and user complains that something is wrong accessing the SalesDB. So we use a CheckDB, and there is definitely a problem. So CheckDB could be very, very red in its output. So let me check in table view DBCC CheckDB in order to be more clear, those messages to be more clear. So what's wrong with this database? Actually, if we go through the messages in this database, we have problem with index ID 2, which is non-clustered index. Beside that, we have a repair level that is recommended by DBCC CheckDB. Always note the repair level that DBCC CheckDB recommends, because if the repair level is repair rebuild, you're just saved. So you could repair the database without data loss, first of all, and you could just not go through the restoring of the database, but use CheckDB in order to repair the error, which means greatly reducing the downtime of your database. So you have a chance of doing that, of performing that. So repair level is very important when we perform the CheckDB against the database. So if I try to fix the error, then I'm going to try to use the repair rebuild. Well, okay, the database, in order to perform the repair rebuilds, needs to be in a single user mode, which is actually downtime. Okay, so because the problem is in non-cluster index, then I will try to make something with this non-cluster index in order to try to not go even into the single user mode, or to keep the database with zero downtime. So let's check the indexes. Actually, this is the index that I have problem with. This is the customer name non-clustered index. So I will try to just rebuild the index. Well, if I try to rebuild the index online, it's actually using the same structure, and it's something that will definitely not work. So I have to try to rebuild the index offline. So if I check again, you see that this is not a solution. So I probably have to just drop existing non-clustered index and try again. But in order to save some time, now in the presentation, I'll directly make the things work with dropping the index and creating the index again. So now let's check the thing. That's fine. So even with the database corruption, or when the database corruption happens, it is not necessary to go directly to restoring a database, or to go directly to have the downtime of the database. Just check. We have to check DBCC CheckDB. Probably we can take a chance to reduce greatly the downtime and to not go to the last resort of restoring a database, or even setting it in emergency state or something like that. So first of all, we need to discover a database corruption, what is happening, to run and to wait the DBCC CheckDB to complete, to find out what is the proper level of restoring that CheckDB recommends, repair rebuild, or allow data loss. So if it is repair rebuild, then we have a chance. We should use the chance to recover the user database. If the DBCC CheckDB outputs allow data loss, then you probably better go to restore the database from the backup rather than use DBCC CheckDB, because when you use DBCC CheckDB, you don't know how much data you lose. So it's really a last resort if you don't have backups. Very important is to not change your plan in the middle. For example, I had this scenario, I had this case in the customer. I told him on the phone, just run DBCC CheckDB and call me after that. So they run DBCC CheckDB. They just they thought that it's going a lot of time it takes to run, and they just stop and kill DBCC CheckDB process. And after that they go to recovery, and it was a lot of time taken and a lot of downtime because of changing the plans in the middle. So keep your disaster recovery or failover plan or corruption survival plan. It's better than to press the panic button. As a summary, so the main point of my session today was to push you to check those settings in order to gain the maximum of your performance, at least first at the configuration level. Almost all of those settings do not require downtime. They are easy to implement. They are easy to check and change, and they do not. You don't have to perform some additional investments in hardware or in software in order to gain these performance benefits. Of course, don't forget the SQL Server level settings is a whole other new presentation session about just SQL Server level settings. For example, you always have to configure max server memory on your SQL Server. There are some exceptions in virtual environment with live switching between the hosts, but I'm not going to go into details on this right now. You optimize for ad hoc is a good way to go, and test for ad hoc queries and reducing the memory and caches for ad hoc queries. Always configure tempdb properly, and consider adding some trace flags that could potentially save the time and concurrency, for example, for tempdb or for statistics update for large tables. Always test your maintenance plan and follow your checklist now and for everything in your SQL Server environment. Thanks for your patience. Thanks for listening this presentation. Thanks for inviting me, and hopefully it was useful for you. These are the links of SQL Server Master Academy. This is my email address and my personal website. Please email me if you have any questions. Don't hesitate to email me, or just go to this site to check the next event of SQL Server Master Academy. Thank you very much.